Hello, in this video, I'm going to go over the graphing quadratic function worksheets. They can be found in the worksheet tab on your Ivy Learn home page. They're the 11.1 graphing quadratic worksheets right here. Since I have already covered the content and how to do these in another video, I will basically be working these out, and you should be checking your worksheet to make sure you have the correct answers. So let's get started. I'm always going to write what A, B, and C are. We know the graph opens up because A is positive. The graph is going to be the same width as the graph of f of x is equal to x squared. The axis of symmetry we find by calculating x is equal to negative b over 2a. To find the vertex, we then find f of negative 2. You're going to substitute in negative 2 in the function for your x values, and when you do, you will get a value of negative 9. So the vertex is at negative 2, negative 9. To find a y-intercept, you set x equal to 0. To find an x-intercept, you set y equal to 0. And I'm going to work it out at the top. So our x-intercepts are at negative 5, 0, and 1, 0. Since the graph opens up, the graph will have a minimum value, and that minimum value is the y value of your vertex, which is negative 9. Plot the points and graph it. And again, we know by symmetry, if we know the y-intercept, we know where we can plot the other point. I'm not really super proud of my graph, but you get the idea. All right, moving on to number 2. Notice the order. So A is equal to negative 3, B is equal to 6, and C is equal to 0. Because A is negative, it's going to open down. The graph is going to be narrower because the absolute value of A is greater than 1. The equation of the axis of symmetry we'll calculate by calculating negative b over 2a. To find the vertex, we need to find f of 1, substitute in 1 for x, and we get 3. To find the y-intercept, you set x equal to 0. To find the x-intercept, you set y equal to 0. So we have x is equal to 0 and x is equal to 2. Because the graph opens down, we have a max value, and the max value is the y value of your vertex, and that value is 3. You have all the components to graph your parabola. And that's how you do it. Example number 3. The graph is going to open up because a is positive. It's going to be the same width as y equals, or f of x is equal to x squared. The axis of symmetry, we calculate by negative b over 2a. To find the vertex, we find f of negative 3. We substitute in negative 3 in the function, we get negative 4. To find the y-intercept, we set x equal to 0. To find the x-intercept, we set y equal to 0. And we'll factor. So we know that x is equal to negative 5 and negative 1. Write those as intercepts. Because the graph opens up, it will have a minimum, and the minimum will be at the y value of our vertex. We have all the components. Let's graph. There you have it. Example number 4. A is equal to negative 1/2. B is equal to 1. And C is equal to 4. Because A is negative, we know the graph will open down. Since A is a fraction between 0 and 1, this will make the parabola wider. Axis is symmetry, x equals negative b over 2a. To find the vertex, let's plug 1 into the function. F of 1 is going to equal 9 over 2, but it will probably be easier if we write this as a decimal, 4.5. To find the y-intercept, set x equal to 0. To find an x-intercept, we will set the function equal to 0. I don't particularly want to try to factor with a -1/2, so I'm going to multiply the entire equation by a -2. And now this is much easier for me to factor. That'll factor into x minus 4, x plus 2. So I know my x-intercepts are going to be 4, 0, and -2, 0. Because the graph opens down, we will have a maximum value. Maximum value of the vertex is 4.5. And then we'll graph this. There you go. Number 5. So you might have already figured out that the x-intercept is going to be at -1, 0, because the x-intercept is also the vertex. And because the graph opens up, we're going to have a minimum. The minimum value of our vertex is at 0. So we'll go ahead and graph this. And we know the y-intercept is at 0, 1, but we need a point on both sides of our vertex. So by symmetry, we can plot the other point and graph our parabola. And finally, number 6. We know that this graph opens down because A is -2. We know that it's going to be narrower because the absolute value of A is greater than 1. The axis of symmetry. Since B is equal to 0, the axis of symmetry is x is equal to 0. Plug in 0 for x. The result is -4. So we know that the vertex and the y-intercept are going to be the same. To find an x-intercept, we're going to set our function equal to 0. And then if we divide both sides by 2, we have x squared plus 2 equals 0. And we're thinking, hey, something's not right here, and you are correct. So if we think about this, if we go to 0, -4, and put our vertex, and we know that this graph opens down, we know that the x-intercepts do not exist. So do not exist is abbreviated D&E. Does not exist. So now what are we going to do to try to get a point on either side of our graph? Well, in this particular case, we're going to have to make a table of values. Because we have the vertex at 0, -4, so we need to figure out a point on either side of the vertex. So if we calculate f of 1, substitute in 1, we will get -6. And if we substitute in -1, we will also get -6. So now we have a point on either side of the vertex. So we can draw a parabola. We know that the graph has a maximum, and then the maximum value is the y value of the vertex. There you go.